लो क्लास चालू करते हैं अब। केस टू, रिजर्वर एम्प्टी केस। Empty reservoir without earthquake force to be computed for determining bending diagram, etc. for reinforcement design for grouting studies or other purposes. किस किस के लिए यूज आता है? reinforcement design, grouting studies और other purposes. grouting क्या होती है पता है ना सबको? ग्राउटिंग वो प्रोसेस होता है जिसके अंदर अपन क्या बोलते हैं, सीमेंट या कुछ अगर खड्डा वड्डा कुछ हो तो सीमेंट वेमेंट या बाइंडिंग मटेरियल इंजेक्ट करके वहां तक पहुंचाया जाता है जहां पर उसमें क्रैक्स या खड्डे डेवलप हो चुके हो स्ट्रक्चर के अंदर, ठीक है ना? Empty reservoir with a horizontal earthquake force towards produced towards the upstream has to be checked for non-development of a tension at a toe. फिर है modes of failure and criteria for structural stability of gravity dam. A gravity dam may be failed in following ways. पहला है by overturning about the toe. ओवरटर्निंग हो गया हो, ठीक है ना? बाय क्रशिंग, खुद के सेल्फ वेट से क्रश हो गया हो. बाय डेवलपमेंट ऑफ टेंशन कॉजिंग अल्टीमेट फेलियर बाय क्रशिंग. बाय shear failure called sliding. The failure may occur at the foundation plane or at any other plane at higher level. फर्स्ट है ओवरटर्निंग फेलियर. If the resultant of all the forces acting on a dam at any of its section passes the toe, the dam shall rotate and overturn about the toe. Practically, such a condition shall not arise, as the dam will fail much earlier by compression. The ratio of righting movement about the toe to the overturning movement about the toe is called the factor of safety against overturning. Its value generally varies between 2 to 3. कंप्रेशन एंड क्रशिंग. कंप्रेशन एंड क्रशिंग के अंदर ये देखो, ये है प्लस माइनस, बता देता हूँ. A dam may fail by the failure of its material, that is, the compressive stress produced may exceed the allowable stresses, and the dam material may get crushed. The vertical direct stress distribution at the base is given by the equation P is equals to direct stress plus bending stress. P max या P minimum is equals to sigma V upon B into 1 plus minus 6 E by B. Where E is equals to eccentricity, ये स्मॉल ई ही है, यहाँ पर कैपिटल ई लिखा हुआ है, यहाँ स्मॉल ई ही है ये. E is equals to eccentricity of the resultant force from the center of the base. Sigma V is equals to total vertical forces कितने लग रहे हैं? B हो जाएगा बेस विड्थ. ये देख लो, ये ऐसा लगेगा, कंप्रेशन और टेंशन का डायग्राम ऐसे बनेगा. ये तुम लोगों ने आरसीसी के अंदर भी देखा होगा कि अगर बिग बीम के अंदर कंप्रेशन और टेंशन के डायग्राम कैसे बनते हैं, देखा हुआ है ना? यस और नो? आरसीसी के अंदर बीम के अंदर देखा हुआ है कंप्रेशन और टेंशन के डायग्राम. स्टार्ट आरसीसी इसी से होती है, कार्टूनों. ठीक है, फिर आगे चलते हैं. फिर है थर्ड है टेंशन. मैशनरी एंड कंक्रीट ग्रेविटी डैम आर यूजुअली डिजाइन्ड इन सच अ वे दैट नो टेंशन इज डेवलप्ड एनीवेयर because these material cannot withstand tensile stresses. If subjected to the stresses, these material may finally crack. However, for achieving economy in designs for very high gravity dams, certain amount of tension may be permitted under loading condition. This may be permitted because of the fact that such vast loading conditions shall occur only momentarily for a little time and would neither last long nor occur frequently. The maximum permissible tensile stress for higher concrete gravity dam under the worst loading may be taken as 500 kilonewton per meter square. फिर है इफेक्ट प्रोड्यूस्ड बाय द टेंशन क्रैक. इन द डैम, अब इस पे इफेक्ट क्या क्या पड़ेंगे टेंशन क्रैक के, देखना। इन अ डैम when such a tension crack develops, say at heel crack, width loses contact with the bottom foundation and thus become ineffective. Hence, the effective width B of the dam base will be reduced. This will increase P max at the toe. Hence, a tension crack by itself does not fail the structure, but it leads to the failure of the structure by producing excessive compressive stresses. In order to ensure that no tension is developed anywhere, we must ensure that P minimum is at most equal to 0. Since P max, P minimum is equals to sigma V upon B upon P by B, और P minimum होगा, देखो P मैक्सिमम और मिनिमम का फॉर्मूला प्लस माइनस से वेरी करता है, P मिनिमम में माइनस लगेगा और P मैक्सिमम में प्लस लगेगा, ठीक है ना। एक मिनट। ठीक है, तो E इज इक्वल्स टू बी बाई सिक्स, ठीक है ना। हैंस द मैक्सिमम वैल्यू ऑफ इसेंट्रिसिटी दैट कैन बी परमिटेड ऑन आइदर साइड ऑफ द सेंटर इज इक्वल टू द बी बाई सिक्स, which leads to the famous statement the resultant must lie within the middle third portion of the dam। ये देखो बेस ऑफ द डैम, इस पे कैसे ओल्ड अपलिफ्ट प्रेशर है, न्यू अपलिफ्ट प्रेशर डायग्राम है, द क्रेक ए डैश हैज डेवलप्ड नो टेल वाटर, तो ये वाला हो गया। देख लो इस पे कैसे कैसे डेवलप हो रहे हैं, नया प्रेशर कैसे जनरेट हो रहा है, पुराना प्रेशर कैसे जनरेट हो रहा है। स्लाइडिंग, sliding or shear failure will occur when the net horizontal force above any plan in the dam or at the base of the dam exceeds the friction resistance developed at the level. The friction developed between the two surfaces is equal to sigma h less than mu sigma v, or mu into sigma v upon sigma h greater than 1. Mu into sigma v upon sigma h represent nothing but the factor of safety against the sliding, which must be greater than unity, मतलब एक से ज्यादा होना चाहिए। In low dams, the safety against sliding should be checked only for friction, but in high dams for economical precise design, the shear strength of the joint is also considered. Then the equation for factor of safety against sliding which is measured shear friction becomes as Fs is equals to mu sigma v upon sigma h plus b into q, where b is equals to width of the dam at joint, q is equals to average shear strength of the joint, which varies from about 1400 kilonewton per meter square for poor rocks to about 4000 kilonewton per meter square for good rocks. The value of mu generally varies from 0.65 to 0.75। ये होता है स्लाइडिंग फेलियर, ठीक है ना। कहाँ से किस किस पोर्शन से स्लाइड हो सकता है डैम, वो ध्यान रखना होता है। अधिकतर फाउंडेशन से ही स्लाइडिंग फेलियर जनरेट होता है। फिर है स्टेबिलिटी एनालिसिस। द स्टेबिलिटी ऑफ ग्रेविटी डैम कैन बी अप्रोक्सीमेटली एंड इजीली एनालिसिस बाय टू डायमेंशनल ग्रेविटी मेथड and can be precisely analyzed by the three-dimensional method. Stability analysis, gravity method, or two-dimensional analysis. The primary analysis of all gravity dam can be made easily by isolating a typical cross-section of the dam of a unit width. This section is assumed to behave independently of the adjoining section if the vertical transverse joint of the dam are not grouted or keyed together, this assumption is nearly true. Hence, for U-shaped valleys where transverse joints are not generally grouted, this assumption is nearly satisfied. But for narrow V-shaped valley, where the transfer joints are keyed together and the entire length of the dam act monolithically as a single body, this assumption may involve appreciable error. Assumptions क्या क्या considered करना है इसके अंदर ये ध्यान रखना. पहला है the dam is considered to be composed of a number of cantilever, each of the width is 1 meter thick, and each of which act independently of the other. No load is transferred to the embutment by beam action. The foundation and the dam behave as a single unit, the joint being perfect. The material in the foundation and the body of the dam are isotropic and homogeneous. The stress developed in the foundation and the body of the dam are isotropic and homogeneous. No movement of the dam caused by the transfer of load. उसमें कोई भी ट्रांसफर नहीं होगा, ये लोड लगने पे ये ध्यान रखना है. वो स्टेशनरी की स्टेशनरी रहेगी. प्रोसीजर क्या होता है ये देख लो. एक चीज बता दो, स्टेबिलिटी एनालिसिस का प्रोसीजर इंपॉर्टेंट नहीं है, केवल ये तुम लोगों को एज ए नॉलेज के रेस्पेक्ट में किया है. स्टेबिलिटी एनालिसिस का न्यूमेरिकल अगर आएगा तो उस पर केवल फेलियर्स के न्यूमेरिकल आते हैं, जो तुम लोगों को फॉर्मूले याद करने हैं वो नोट्स के अंदर दिए हुए. ठीक है, फिर इसके केवल ये प्रोसीजर बता रहा हूँ. पहला है एनालिटिकल मेथड. कंसिडर्ड यूनिट लेंथ ऑफ द डैम, work out the magnitude and the direction of the vertical forces acting of the dam and the algebraic sum that is sigma v. all the मतलब सारे के सारे vertical forces calculate कर लो. Similarly, work out all the horizontal forces and the algebraic sum sigma h. Determine the lever arm of all these forces about the toe. Determine the movement of these forces about the toe and find out the algebraic sum of those movement, that is sigma m. देखो, find out the location of the resultant force by determining its distance from the toe. X x bar is equals to sigma m upon sigma v. Find out the eccentricity E of the resultant R using v by 2 minus x bar. It must be in order to ensure that no tension is developed anywhere in the dam. Determine the vertical stress at the toe and the heel, that is PV is equals to sigma V upon B into 1 plus minus 6 E by B. ये देख लो, इस तरह से स्टेप ये सारे कंप्रेशन और टेंशन के फोर्सेस लगेंगे इस पर. फिर determine the maximum normal stress, that is principal stress at the toe and the heel. They should not exceed the maximum allowable value. The crushing strength of the concrete varies between 1500 to 3000 kilonewton per meter square per meter cube depending upon the grade. M15 to M30. Determine the factor of safety against the overturning as equals to sigma stabilizing moment plus होगा और distribution moment minus होगा. Plus positive sign is used for anti-clockwise movement and negative sign is used for clockwise movement. Determine the factor of safety against sliding. Graphical method. In the graphical method, the entire dam section is divided into the number of horizontal sections at some suitable intervals, particularly at the place where the slope changes. For each section, the sum of the vertical forces sigma v and the sum of the horizontal forces sigma h above that particular section are worked out and the resultant R is drawn graphically. This is done for each section and the line joining all the points where the individual resultant cut the individual section is drawn. This line represents the resultant force and should lie within the middle third. For no tension to develop, the procedure should be repeated for reservoir full as well as reservoir empty case. ये देख लो, ये होगा ग्राफिकल रिप्रेजेंटेशन इसका स्टेबिलिटी एनालिसिस का. Elementary profile of a gravity dam. The elementary profile of a subjected only to the external water pressure of the upstream side will right angled have zero width at the water level and the base width at the bottom. The point where the maximum hydrostatic water pressure acts, in other words, the shape of such profile is similar to the shape of the hydrostatic pressure distribution. When the reservoir is empty, the only single force acting it is the self weight W of the dam and it acts at the distance B by 3 from the bed, B by 3 from the heel. This is the maximum possible innermost position of the resultant for no tension to develop. And such a line of acting of W is the most ideal as it gives the maximum possible stabilizing movement about the toe without causing tension at the toe when the reservoir is empty. ये देखो इस तरह से अपलिफ्ट प्रेशर और ये लगेगा सिग्मा नहीं पीवी इजिकल्स टू सिग्मा वी अपॉन बी 1 प्लस माइनस 6 ई अपॉन 6 ई अपॉन बी इजिकल्स टू 0 सिग्मा वी इजिकल्स टू डब्ल्यू ई इजिकल्स टू बी बाय 6. Therefore, P max P minimum is equals to sigma V by B plus 1 plus 6 by 1 plus minus 6 by B into B by 6. That is equals to 0. P max is equals to 2W by B and P minimum is equals to 0. Hence, the maximum vertical stress equals to 2W by W will act at the heel and the vertical stress at the toe will be 0. When the reservoir is full, the base width is governed by the resultant of the all the forces that is P, comma W and U passes through the outermost middle third point. The dam is safe against sliding. For first condition to be satisfied, taking movement of all the forces above the middle third point, we get W into B by 3 minus U into B by 3 minus P into H by 3 is equals to R into 0 or W minus U into B by 3 minus P into H by 3 is equals to 0. Substituting the value of W, U and P, W is equals to half into B into H into 1 into SC into gamma W, where SC is equals to specific gravity of concrete, that material of the dam, or gamma W is equals to unit weight of water, that is equals to 9.81 kilonewton per meter cube. U is equals to half C gamma W into H into B, where C is the constant which according to USBR recommendation is taken as 1.0. P is equals to half gamma W H into H is equals to gamma W H square by 2. Therefore, equation W minus U into B by 3 minus PH by 3 is equals to 0. B is equals to H under root SC minus C, where B is taken as the value. SC क्या था? Specific gravity, ठीक है ना? Specific gravity of the concrete, ये याद रखना. और ये कांस्टेंट है जिसकी वैल्यू 1 ली है इन्होंने. No tension will be developed at the heel with reservoir full condition. For second condition, to be satisfied, the friction resistance mu sigma gamma or mu W minus U should be equals to or more than the horizontal forces sigma H minus P. Substituting the value of W U P, we get H by mu under root SC by SC minus C. The value of B chosen should be greater of the two values of both the cases. Elementary and practical profile of gravity dam. ये देख लो. High and low gravity dam. इसकी अलग अलग इक्वेशंस है. The principal stresses क्या क्या होते हैं. ठीक है. 1 मिनट होल्ड रखना. F is equals to gamma W into H into SC minus C plus 1. H is equals to F upon gamma W into SC minus C plus 1. H max is equals to F by gamma W into SC plus 1. अब याद रखना इसके अंदर हर एक की टर्मिनोलॉजी दी हुई है। अगर कुछ डाउट आए तो देख लेना, पहले बता दूं। F होगा फोर्स, ये स्मॉल f कर दिया है पर है कैपिटल F ही, ये याद रखना। Hence, a low gravity dam is the one whose height is less than the given equation. If the height of the dam is more than this, it is known as high gravity dam. H max is equals to F gamma W Fc plus 1, where gamma W is equals to 9.81 kilonewton per meter cube, Hc is equals to 2.4, F is equals to 3000 kilonewton per meter square, H max is equals to F gamma W into Hc plus 1 is equals to 3000 upon 9.81 plus Hc कितना होता है 2.4 plus 1 is equals to 90 meters लेते हैं, H max इतना ही आएगा। प्रोफाइल ऑफ अ ग्रेविटी डैम फ्रॉम प्रैक्टिकल कंसिडरेशन। अब मैं केवल ये पढ़ रहा हूँ, इतना ज्यादा काम का नहीं है तुम्हारा। द एलिमेंट्री प्रोफाइल ऑफ ग्रेविटी डैम दैट इज triangle with the maximum water surface at the apex is only a horizontal profile. Certain changes will have to be made in the profile in order to cater to the practical needs. These needs are: first step, provided a straight top vertical for the road construction over the top of the dam. Second step, providing a freeboard above the top water surface so that the water may spill over the top of the dam due to wave action, etc. Profile. The additional of these two provisions will cause the resultant forces shift towards the heel. The resultant forces when the reservoir is empty was earlier passing through the inner middle third point. This will therefore shift more towards the heel, crossing the inner middle third point, and consequently tension will be developed at the toe. In order to avoid the development of the tension, some machinery will have to be added to the upstream side, which shows the typical section along with the possible dimension that can be adopted for the low gravity dam section. It should, however, be checked for stability analysis. ये देख लो, प्रोफाइल ऑफ ग्रेविटी डैम फॉर प्रैक्टिकल कंसिडरेशन. Various consideration is fixing the parameters of the dam section under the top width. The top width of the dam is generally dedicated to the requirement of the roadway to be provided. The most economical top width is 14% of the dam height. It is also taken to 0.55 h की power 1 by 2 is the maximum water depth. Usually the width varies from 6 to 10 meter. ठीक है, इसके बाद अपन अगली क्लास में चालू करेंगे। अब मैं ये बता देता हूं कि मैं नेक्स्ट क्लास है ना, एक मिनट, हाँ मैं अब ये बता रहा हूँ कि नेक्स्ट क्लास के अंदर मैं मेरे क्या बोलते हैं अपने अटेंडेंस लेके छोड़ूंगा। चंद्रा सर की उनकी क्या बोलते हैं, कोई